Hi students, today we see the concept of swapping. So swapping is changing the locations of two files. Here swapping means changing the file from primary memory to secondary memory and moving the file over there in the secondary memory to primary memory. Okay, so this is called swapping, changing the places or interchanging the places of two files between the places main memory and the secondary storage, which is also called as disk. And these are the contents of our concept. We see first about swapping, then we explain swapping with an illustration, then we see an example, then we see what address binding is, then we conclude the concept of swapping. Right, now what is swapping? Swapping is actually a mechanism. As I said, it is a process in which swapping can be done. That is, swapping is a mechanism in which a process can be swapped temporarily out of memory to a secondary memory, which is also called a disk, and make that particular memory available to the upcoming process which is ready. Okay, so when the swapped in process is finished, again the swapped out process will be brought back to the main memory. So this is what is actually done in swapping. So though performance is usually affected by swapping process, it helps in running multiple and big processes in parallel. Okay, so when the main memory is lack of memory space to occupy all the processes, the important process will be given more priority. So to give it the more priority, what we are doing is the currently running process in the main memory is swapped out, and we make space for the important process to run on the main memory. So it makes the important processes running quickly. Okay, so when swapping is done, we are not just finish off the already running process, we just pause it. Okay, so when it is again brought back to the main memory, it will be again resumed and it will be made run. So by this way we can make more than one processes running simultaneously. So swapping is doing that. This is called as swapping, and swapping is also known as memory compaction. Right. So a process, when it has to run, it should be in main memory. So a process that is ready for execution is brought back to the main memory. So this is what I already explained. If a running process gets blocked, the memory manager temporarily swaps out the blocked process onto the disk. So this makes the space for the upcoming process in the main memory for execution. So that's it. Then this is the illustration of swapping. See, on the left you have main memory, on the right you have secondary memory, which is disk. Okay, so in main memory, process P1 is actually running. Now P2 is a process which is ready on the disk. So what we do, the main memory cannot accommodate both the processes. It is in that situation that it cannot handle both the processes P1 and P2. But P2 has to be handled first, then P1. So what main memory decides is, it swaps out process P1 to the secondary memory and it just takes P2 in. So it swaps in P2. Okay. So that is it. P1 is swapped out and P2 is swapped in to the main memory. Right. So this is another illustration. See, on left you have main memory, on the right you have secondary memory. In main memory we have P1 and P2, two processes running. Now in secondary memory we have number of processes from P3 to Pn. Okay. So now P3 is ready. The first process P3 is ready. So the main memory decides to swap out P1 and to swap in P3. So that is happening here. P1 is swapped out and P3 is swapped into the main memory. Okay, now P3 is over. So what is done? P3 is sent again back to the secondary memory. This is swapping out. Then P1 is again swapped into the main memory. So I think this example will best explain you about swapping. Right. So now we talk about the time. Okay. So the total time taken for swapping includes the data exchange or the process exchange from main memory to the secondary memory, or from the secondary memory to the main memory. So the total time taken for swapping is calculated by the time taken for the process when swapped out is done, and also the swapped in is done. Okay, both the times are calculated to calculate the total time taken for a single swapping. For example, we consider a process of size 2048 kb. We know 1 MB is 1024 kb. So this process is of size 2048 kb, which is of 2 MB size, right? So keep this in your mind. One swapping, okay, one data transfer, one swapping takes 1 second of time. In 1 second of time, 1 MB of data can be swapped. Okay, so this is the speed of swapping here. Now, what is the time taken by the process which is of 2 MB size or 2048 kb size? Right, we'll calculate that. The actual transfer of 2 MB process, that is 2048 kb process, takes 2048 kb divided by 1024 kb, which is 1 MB. Actually, we are doing here 2 MB by 1 MB. That's it. Okay. So when 2 is divided by 1, we get 2. 2 seconds we get. 2 seconds is equal to 2000 milliseconds. Right. So it will take, for single process, for the 1K process, 1000K process, it takes 2000 milliseconds. So for 2000K process, it takes 4000 milliseconds, and plus the overhead. Okay, any delay is happening, that time is also calculated. Okay, right. So when is swapping done? Swapping is always based on priority. Okay, for example, see this diagram. P1, P2 are already running in main memory. Now P3 is ready on secondary memory. When P3 will be shifted to P1? When P3 has the higher priority than the process P1 or P2, whatever it is. Okay, when the waiting ready process has higher priority than the running processes, only then it will be swapped into the main memory, and one of the running process will be swapped out. So that's it. It is based on priority based preemptive scheduling. So that is it. Okay, then see the last, this swapping out and swapping in can also be called as roll out and roll in. Right. Now this is another important concept, which is address binding. What is address binding? For example, when a process P1 is swapped out from main memory to the secondary memory, and some other process from secondary memory is swapped into the main memory, right? When the new process completes its execution, it is swapped out, right? Now, the already swapped out process, which is P1, is swapped into the main memory. Now, where the swapped in process occupies, which place it occupies? Okay, will it occupy the same space where it was already there, or it will be accommodated in a new place? So what about this? Right, we see that. Right, see this diagram. The operating system has a process A. See the next compartment, it has 2 processes, A and B. See the next one, A, B, C. 3 processes are running. Now process A is swapped out. Okay, see the 4th compartment, process A is swapped out. Why it is swapped out? We have a new process D that may have a higher priority than A. So to swap in D, we swap out A, right? So A is swapped out and D comes in to the place of A. Now D is running. Okay, see number 5 and 6, D is running. Now what happens? Meanwhile, B completed its execution. So B is swapped out to the secondary memory. Now A, which is already swapped out for D, comes in. It is swapped in. Now A occupies the place of B. See here, A. Actually it should come to the place of D, because that is the place of A. But since D is running on A's place, A comes to the place of B. Okay. So here we mean to say that the swapped out process, when it is again swapped into the main memory, it will not occupy its original place always. It may be accommodated in some other place also. So this is called address binding, right? So we conclude, swapping is a process that occurs when the amount of main memory reaches a critically low point, when then the processes in main memory are temporarily swapped out to the disk, right? So that's it. When the swapping will happen, when the memory space in the main memory is critically low, that it cannot occupy, it cannot accommodate all the processes. What it decides to swap out one process to the disk, then it swaps in the higher priority process in, right? So that is when swapping happens, right? So the swapped out process will be again swapped in when there is a memory in the memory space in the main memory, right? Okay, so that is all about swapping. I hope you understood, and thanks for watching.